Okay, we've been talking about GCF and LCM. If I have two numbers, we now know that 2 and 6 are called, they're called factors because 2 and 6, when multiplied by another number, can go into something else. In this case, the 12 is the product, but it's also a multiple of those two numbers, because if I have 2 times 6, I have 12, and if I have 6 times 2, I have 12. If I have 1 times 12, so we're going to take it one step further. If I have two numbers, 3 and 9, and I ask myself what goes into those two numbers, 2, 3, or 5, I automatically know that 3 would go into both those numbers. I divide it out. In this case, my GCF would be the number on the outside, which is 3. And my LCM would be all the numbers on the outside. Because the only time I draw another line going underneath the cake is when I can actually keep dividing. So I draw my L. 3 times 1 is 3. 3 times 3 is 9. In my way to check the GCF, I know that this number has to be able to go evenly into both of those numbers, not just one. And I know that 3 goes into 3 one time, 3 goes into 9 3 times, so that must be right. And my LCM is 9. And I know that if I take these two numbers times something, I can get 9. Well, 3 times 3 is 9. 9 times 1 is 9. If we take it one step further, we're going to go to 3 numbers. This is where it becomes a little more difficult. I have 3 numbers and I want to find the GCF. So I do like I always do. I start with the numbers 2, 3, or 5. And I know that 5 goes into all 3 numbers. 5 goes into 5 one time. 5 goes into 15. 5 goes into 30 6 times. So what is my GCF? 5. GCF is 5. Because in order to be a factor, that number has to go into one number.
No.
2 numbers?
No.
3 numbers?
Yes.
In order to be a factor, it has to go into all numbers. Okay? Because I could look, I have 3 and 6. Well, 3 goes into 3 and 6, but does 3 go into 1? Then my factors are done. But guess what? My LCM is not. So, when you have 3 numbers and you get to a point where you can't divide something into all 3 numbers anymore, write your GCF down. Otherwise, you will get confused. If I have at least 2 numbers that still share something in common, I continue with the LCM. I've got my GCF already done. Now I do the next step. So, I make another cake line. And what two numbers have something in common?
3 and 6.
3 and 6. What goes into both those numbers? 3. So, does 3 go into 1?
No.
If it does not go into a number, you just bring the number down. Okay, so I'm going to take my 1 and I'm going to bring it down. Because I don't even worry about the 1 anymore. I'm done with the 1. How many times does 3 go into 3?
1.
And 3 into 6?
Twice.
Okay, now we're going to look at our numbers again. Do I have at least 2 numbers that have something in common besides 1? No. I'm done. Does this mean now that I have another 3 there that my GCF is now 15? Your GCF cannot be 15 because that would mean that 15 would also go into 5. And would that work? No. Remember, you stopped at GCF a long time ago. But now we have the LCM. And to find the LCM, you draw your L and you multiply all the numbers on the outside. So I have 5 times 3 is 15. 15 times 1 is?
15.
15 times 1 is?
15.
15 times 2?
30.
My LCM is 30. Well, let's check. Tell me the first few multiples of 5.
5, 10, 15, 20, 25, 30, 35, 40, 45.
Okay, we can stop. Because I already know for a fact that LCM is 30 because I've already worked it out this way. But if you want to go back and check, go all the way up to 30 and stop. And then we have 15. My first few multiples of 15 to 30 are what? 15 and 30. And then my multiples of 30 are 30. So let's look at these numbers. Is there anything in front of the 30 on any of these that's in common? Well, we have 15 and 15, don't we? But does 30 share that multiple? And remember, in order to be a common multiple, all the numbers in this set have to share the same smallest multiple or least. So 30 is the first number we have where they all 3 have it in common. Okay, we'll try one more. I have the numbers 9, 21, and 42. If I start with 2, 3, or 5, which number would go into all 3? 3 would go into all 3 because I know that 3 goes into 9. 2 plus 1 is 3, and 3 goes into 3. 4 plus 2 is 6, and 3 goes into 6. So I know automatically that 3 goes into all 3 numbers. 3 goes into 9. 3 goes into 21. And 3 into 42. 16. What's my GCF?
3.
And my LCM, what do I need to do?
Make your L around all of the 4 numbers.
Okay, why do I make my L? What do I need to do before I do that?
Make sure that nothing goes into the 3 numbers on the bottom.
Okay, well, here's a problem though. There's something not quite right about this problem. When we were busy saying the answers, something went wrong.
Oh, yeah.
So, what should we always do when we're dividing out a number? Just write down whatever everybody else is saying? What do we need to do?
You need to check your work.
Check your work. I was thinking this did not look quite right now. There's something not right. How many times does 3 go into 4? Once. Remainder. How many times does 3 go into 12? 4. Now let's look at this again. Do all 3 of those numbers have something in common?
No.
So I'm done with the GCF. Correct? Do 2 of those numbers have something in common?
Yes.
What 2 numbers have something in common?
7 and 14.
7 and 14. So, guess what? I'm going to go draw another line. And what goes into both 7 and 14?
2.
7 goes into both 7 and 14. Does 7 go into 3? What do I do with my 3? Bring it down. I don't need 3. How many times does 7 go into 7? And 7 into 14? Do I have at least 2 numbers that have something in common besides 1? Am I done? Yes. Draw the L. Multiply. Are you going to be able to do this in your heads? Probably not. 7 times 3 is 21 times 63 times 1 is 63 times 2 126. Now remember, the way to check your work would be to take all the multiples of 9, go up to 126, all the multiples of 21 up to 126, all the multiples of 42 up to 126, and make sure it's the smallest common multiple.